Hey guys, Miss Harper here to go over your Unit 3B test review. Alright, we're going to go ahead and start here on number 2. Now number 1 and 2, you're going to work pretty similar, and even number 3 and 4. So first thing, we need to know what our point slope formula is, and the other helpful formula will be our slope formula. And so if you look here at number 2, they actually did not give us the slope this time. So first I need to identify what that is first. So m equals, remember you can label these points. So I will have y2 minus y1 over x2 minus x1. 2 minus 1 is 1. 0 minus 3 is negative 3. So my slope is going to be negative 1/3. After you've identified your slope, now you pick out a point and you plug it into your point slope formula. Now I'm going to show you how to do that. So this would be, let's say I choose to work with this point. Alright, my x1 and y1. So I would have y minus, y1 is 1, equals m times x minus, the x value was 3. Then I can distribute. I have y minus 1 equals negative 1/3 x plus 1, and my last step to solve for y is going to be adding this 1 to the other side. Y equals negative 1/3 x plus 2. Now another shortcut you may have recognized, remember I really try to encourage y'all, recognize this point as a y-intercept. If you can recognize that as a y-intercept, then all you needed to do was identify your slope and plug that into your slope formula, and then positive 2 would be your y-intercept there. Alright, now you're going to do number 1 the exact same way you did this problem, except it already gave us our slope. Alright, we're going to check out number 4 this time. Number 3, you're going to work the same way. Remember what we know about parallel lines is they have the same slope. So you're going to use the same slope and then do the point slope formula. As we move next door here to number 4, now we're talking about perpendicular slopes. So we need to remember what happens with our perpendicular slope. If my current slope of this line is 4 over 7, what should my new slope be? Remember, opposite tells me to change the sign. So this was positive. Now this is going to be negative. Reciprocal tells me to flip the fraction. So negative 7 over 4. And then I have my x1 and y1 point. And now I can plug into my point slope formula. So y minus 2 equals m times x minus x1. Now remember right there we call that a double negative and they change into a giant positive. From there we can distribute and solve. So I have y minus 2 equals negative 7/4 x. That's going to be minus 7 if you plug that into your calculator. Negative 7/4 times 4 would be negative 7. In our last step to solve for y, I'm simply going to add this 2 to the opposite side. Get rid of that. I get y equals negative 7/4 x. Sorry about that. Minus 5. And that would be my final answer. Remember to take the extra 2 seconds to plug your answer choice back in. So if I plugged in my x and y value from my point, so I have negative 7/4 times my x value, which was negative 4, minus 5 for the rest of my equation, and it should equal my y value, which is correct. It was 2. So negative 4, 2. Make sure you take the time to plug that point back in. Alright, shimmying down here, we're going to look at number 6. On number 5, real quick, make sure that first, before you solve this thing, that you solve for y. Alright, so that means you need to add this 2x to the other side. And then you're going to have to divide by a negative 1 to get rid of that negative y. And then you can graph from there. Now, this one is a special case, which is why I wanted to refresh you on this. Hoi vux. Whenever you have that special x equals equation, this one is x equals negative 4. That means it's going to cut through my x-axis at negative 4, and it's going to be a vertical line. And that's it. The next one we're going to look at is number 7. All right, reflect the parent function over the x-axis, shift it down 2 units, and make it steeper by a factor of 4. And what is your new equation? Well, first you need to remember what is the parent function, and that's y equals x, or y equals 1x plus 0 to break it down a little further. Has a slope of 1 and a y-intercept of 0. All right, so remember that the reflection part, reflecting over the x-axis, that will change my slope from positive to now negative. A shift down 2 units, that's going to be adjusting my y-intercept. And then to make it steeper by a factor of 4, that means my new slope is now going to be positive 4. All right, so now that we know those different pieces, let's work with what our new equation should be. So first of all, reflection tells me that my new slope needs to be negative. Making it steeper by a factor of 4, that means my slope should be now negative 4. And then to shift it down 2 units, my y-intercept is going to now be at negative 2. And that is how we do those. All right, looking at number 8, it says it's if h of x is equal to 3x minus 5 and you shifted the graph up 7 units. Again, this is talking about a y-intercept whenever we're shifting things up and down. What would the new equation be? So if you think about it, if I'm down here at 1, 2, 3, 4, 5, negative 5 for my y-intercept, and it wants us to shift it up 7 units, well, that would be up 5, 6, and 7. All right, so that means basically you're adding 7 to your y-intercept, putting us at a positive 2. Nothing changed with our slope. All we changed was our y-intercept. Negative 5 plus 7 is positive 2. On to the next side, we're going to look real quick at number 9. It says to sketch the graph of the line given the following information. It wants it to go through the point 0, 4, which is right here, and be perpendicular to the line x equals 2. So let's remember what the line x equals 2 should look like. Well, that's going to be a vertical line through my x-axis. So I go to my x-axis at negative 2, and it's a vertical line. So here's the first equation, our given graph. X equals negative 2. Now my new line needs to be perpendicular to that. Remember, perpendicular lines intersect at a right angle. And it has to go through this given point. So what kind of line am I looking for? Well, it's going to be a horizontal line. All right, our horizontal lines, those are special cases. Now you should be thinking HOI. And that's going to be a special y equals. And where does it cut through our y-axis? And that is at 4. So our equation there would be y equals 4. All right, the next one we're going to look at real quick is number 12. All right, on number 12, given that y varies directly with x, so these are the ones where you have to remember it's y over x equals y over x. All right, so take your first pair that it gives you. Here's my first xy. So I'm going to put y on top, x on bottom, equals what is x when y is 5? So again, y should go on top, x goes on bottom. You multiply the two numbers across from each other, and then we're going to divide by this third number here. So negative 4 times 5 is negative 20, and we can do this in our calculator. Negative 4 times negative 5. Oh, I think it was positive 5. Negative 4 times 5 is negative 20. And then we're going to divide by that last remaining number, which was 5. Nope, I lied. It's negative 2. So, sorry, let me try that one more time. Negative 4 times 5. And then we divide by the third number, which is a negative 2. So divided by negative 2. And we get 10. So in this case, x is equal to 10. All right, now we're going to flip over to the back. Talk about a little domain and range. All right, so first of all, I'm not going to go all the way over number 15, but hopefully you recognize this one to be discrete. This means the old-fashioned way. If I were you, I would make out an XY table, and I would list out each of my coordinate points here first, and then I would do it the old-fashioned way and list out those individual numbers. Let's check out number 16. So remember how to do these ones whenever we're talking about continuous graphs. This one is continuous. It's a graphed line of some sort. So first I'm going to work with my domain. That means I'm only looking at my x-axis. All right, on my x-axis, I want to mark up the furthest left and the furthest right my graph is going to extend. So if I look for the leftist most point, that would be right here, and my rightist most point would be right here. Then I can read my x-axis from there. So furthest left is at -1, -2, -3, so -3. And it's a closed circle there. Then the furthest right I reach is 1, 2, 3, +3. And again, oh, actually there, it's actually an open circle. So this one is not going to get the equal to symbol. So it's going to be less than +3. Okay, now looking real quick, now we're going to shift gears and look at just our y-axis. Looking at our y-axis here. Now I'm going to find least to greatest would be bottom to top. So I'm going to find my lowest point, and that's right here, and I'm going to mark that through my y-axis. Can find my highest point, mark that through my y-axis there. So the lowest my graph is going to reach is -1, 2, 3, 4. So that's -4. There at -4, it's a closed circle. We're talking about our y values. And then the highest point is going to be at 1, 2, 3, 4, 5. And again, up there at 5, it's another closed circle. Okay, number 17, you're going to have a special case on your, I'll tell you just the domain. You can mark up for your y-axis, but for the domain, if you notice, it's going to extend forever and ever to the left and forever and ever to the right. So your domain here should be all real numbers. Then you have some vocab down here at the bottom. Look through your notes. Use Google whenever you're looking for the definitions of these terms, or look through your notes. Try to make the most sense of these things, as you will see a matching vocabulary section on your test. Good luck. If you have any questions, please come see me before school, before your test, so I can answer those with you. Thank you.